This is Unevenly Distributed, a podcast from nexavize.com, where we talk to experts to find out what's next in digital technology and where it's real today.
This is Unevenly Distributed, and I'm Jeff Villamek. I'm joined today by a longtime friend, Charles Stacy Harris III, to talk about the Internet of Things. Stacy's an innovation lead at Microsoft and an architect leading technology conversations at their Detroit Microsoft Technology Center, which is an awesome place. Stacy, welcome.
Hey there. Good to be here. Glad to see you.
I'm glad you're here. I know we've been catching up a little bit lately. I've visited the Detroit Center probably, a year ago or 6 months ago?
Yep.
Great place.
Yep.
But I wanted to get somebody on that has been working with IoT, that has been playing with IoT. And you and I go way back, and I know that you've been in technology a long time doing this stuff. So I'll do a little bit of intro on IoT here, and then we'll get to what your perspective is on it too. And then we can throw in some of our stories from the past. Last time we worked directly together on a project was probably in the 90s, but we weren't doing IoT back then.
It's been a while. Yeah.
So IoT, the statistics that I was finding is that there's 14 billion IoT devices connected to the internet today. That's around 2 devices for every person on the planet, which is pretty interesting. I counted up almost 30 in my house, and that's not including like the PCs and tablets and phones. That's internet connected devices. And if you look just at cellular, there's around 2 billion that are just cellular connected. So really the opportunity to have all these devices all over the place connected wherever they can connect. There's all kinds of IoT devices. There's single purpose, tiny little sensors that just grab some data. There's small devices that are kind of smart, like these plugs that I'm holding and waving around and fiddling with that do a job. There's larger complex devices like everything from the coffee and tea machine I have behind me that I actually talk to through the internet to make me coffee and tea every day, up to smart cars. And then one thing that we'll probably brainstorm a little bit on is you start getting bunches of these things together and you can start to take whole factories and connect them to the internet, or cities and smart cities and that kind of thing. So that's kind of the breakdown of what I think about when I think about IoT is these constellations of devices from very small to very large networks of these things. So that's in my head. What's your take on IoT, and what have you been doing with it lately?
Yeah, so I think I have a very similar take. And my journey with IoT starts years back before people were saying the phrase IoT. In fact, there's a few thoughts going in my head, but I did a podcast, .NET Rocks, years ago, where I had built a home automation system from scratch, just custom coded and custom built devices and things like that. And back then, my goal was to just take ordinary things, like anything that you just do on a routine basis, and think about, can I automate it? So, for example, just simple things like I open a door and close the door and a light goes on and off. Well, yeah, you could do that with a little door switch. But in our kitchen, for example, we had this really nice decorative pantry door that has a glass panel, still has a glass panel. And sometimes, especially if you have guests over and things like that, it looks pretty cool when that light is still on and glowing through the glass panel. And with just a dumb switch, I couldn't do that. So, of course, I replaced that with a contact sensor and did my own software behind it. Things like that are kind of fun and convenient, having lights come on when you walk around, but also things that can, with a little bit of investment, like what can I automate that with just a little bit of investment could save me a lot? So, yeah, the obvious things like turning lights off. But in my house, we actually have a sump pump. And one winter, our sump pump ejector line decided to freeze and the water decided to come up. And I am so glad I had a really inexpensive water sensor sitting there that would just tell me that there's water on the floor. And we were able to get to that. Actually, it was even before it got to the floor. In this case, it was down in the ejector pit for the sump pump. As it hit a certain level, then that sent me an alert, and we were able to stop the madness before we could have had thousands of dollars worth of water damage in our basement. We were able to just stop that. And if you think about, that's cheaper than insurance to go out and buy a little sensor. In this case, a little battery powered cheap sensor that you could just stick on the floor,
Yeah.
and now you know. And I ended up putting them under every sink in every room, every bathroom, kitchen, and laundry room. They're everywhere now. And a couple of times, it's come up where water started to overflow in something, and we were able to stop it. So I think about things like that.
That's where a lot of this got started. This was the kind of where can we start putting some of these sensors, connect them to the internet, get information off of them, and be reactive. And you have that's an excellent case. And I have cameras in a couple places, and then I have some reactive sensors that are watching some things like, did I leave my garage door open? And it texts me at night if it's open. So you saving a couple $1,000s because you avoided water damage in your basement, that's great. And then I think what's evolved from then over the course of the last decade is a company or a city saving millions or hundreds of millions of dollars by being able to watch what's going on and tune what they're doing. That's where that's grown from. So that's a microcosm of what Internet of Things is sort of becoming, and then where it's going to go is even an order of magnitude more useful.
Oh, absolutely. In fact, we have a customer who I can't mention names, obviously, but who ended up doing something very similar because of the stories that we were telling and the things that we were talking about with IoT. And their initial goal was monitoring power usage in their factories, but someone decided, hey, while we're at it, we have all of these chemical lines and these basically pipes that pump chemicals around. And yeah, we know what the pressure is and we know the flow rates, and they know a lot of that stuff, but why not just throw a bunch of sensors around to look for leaks? And interesting thing is they were able to catch one when it was still at the drip stage and before it became sort of a toxic mess, just by having these extra sensors around. It was the kind of thing where you wouldn't have noticed the difference in the amount of liquid that was going through this pipe, except for this sensor catching a few little drips coming off of one of the joints. And that was like, wow, okay, yeah, they regularly inspect this, but this was a case where you could catch it before the inspector even had to go out and look at it. So,
Right.
Even I don't know how often they inspect, but imagine even if you inspect these things once a day, a few hours could be the difference between drips and a burst pipe.
Yeah. And as we talk about this, and I kind of put it in the same category, but we're conflating the sort of the sensors, which might not be connected to the internet. In a factory, it might be tons of sensors connected to an on-premise system, but they could be connected to the internet as well. The use cases, those stories, are similar to what we're getting out of that kind of sensor set. The really interesting thing is when we start to, and this is why there are 14 billion of these internet connected devices. When we start to get more and more of these sensors, it's not only, hey, here's a water sensor, and when the water hits the water sensor, we get a notice that there's water hitting the water sensor. That's fine. That's tier one. When we get 15 sensors all around a machine, and they're measuring the voltage, the RPM, the vibrations, the temperature, the odors coming off of it. We were experimenting with smells, electronic noses and smell sensors. And that constellation of sensors then, taking all of that data, putting it into a model, either just a statistical model or a machine learning model, and learning what the error conditions are and devices as that constellation of data gets more and more complex. That's where things get really interesting. So even in our houses, I think there was one of the Microsoft distinguished engineers did a talk for Avanade like 3 years ago, and he had internet sensorified his house and had data coming into some sort of report that was looking at temperature and voltage and power consumption on a few different things around his hot tub, and basically discovered that that his daughter was bringing her boyfriend over to use the hot tub on the weekends by looking at the constellation of data. So
I think that's a standard AI model now. It's the
you can
boyfriend in
buy
the hot tub model. Yeah.
you can buy that. What are my kids doing with the hot tub .com API, open source API. I think we all need that. So yeah, that's really interesting. We've got all these devices. We've got all these sensors. So just the sensor set, and there's a whole bunch of work that needs to go on to make the sensors able to only give us the information that we want and need. Because again, with 14 billion of these internet connected devices, a large majority of them being sensors right now, that's actually too much data to be shoving over the network all the time. So this is where we get into concepts like, and we don't need to get too deep into it, but edge computing and data processing at the edge. Let's look at all of that data. Let's munge that data at the edge before we get it, and then we'll do some things with it.
I think you're right. I think one of the danger zones, though, and this is something we work with our customers on all the time. They're like, well, what data do I need to collect? And we don't always know, right?
Right.
So one of the danger zones that we see is that people want to curate the data way too early in the process. So when you start out, maybe you do collect everything just for a little while, and we can see, can we make use of this? Is this valuable data? Because there are times where you just don't know if that data is going to be valuable, and you could be throwing away some information that may not look like much now, but when I get enough of it and I do the analytics around it, could really be valuable information.
Yeah, that's a really good point. I used to say this with clients. There's a lot of data out there, and we can get a whole bunch of data, and we want that data. But the data is the answers, and the harder thing to do is figure out what the right questions are. So you get all of that data, and then you start asking and figuring out what new questions you can start to ask, and that's what data science is. So data science says, all right, we've got all this stuff. What questions could we ask? Now we can start saying, what's the most efficient way to go about this? What factors we start bringing in outside feeds, like the weather and the air pressure and humidity, and finding out when it's a really humid day outside, it tends to make the garage door stick, and that's why the garage door is opening. Or on a broader scale, it's making our factory run less efficiently, and we're losing $1 million a year because we're getting more breakdowns because we're not adjusting the running parameters of our devices based on this information we didn't have before and questions we couldn't ask.
Right. Yep, absolutely.
So that's one stage, is getting all of the sensors, watching the sensors, and then figuring out what questions we want to ask and doing things with that data. I think the next place it starts to get really interesting is when the device itself starts to get intelligent. So the device itself has a bunch of sensors, and it's connected to the internet, and maybe it goes off and asks questions on its own or talks to other devices and then does a thing. Smart machines, smart devices, all the way up to, automated self-driving cars and things like that, I kind of put into this category. That's one set of them. The Amazon Echo, which I do not have plugged in because she would be talking to us this whole podcast. but this kind of thing, which is an internet connected device, goes off to the internet to find more information and ask questions about what I'm asking it, and responds back to me and has artificial intelligence built into it. There's interesting things there when the devices themselves start to get smart and use both the sensors they have, external sources of data, and then even API calls to do interesting things.
Right.
I know you have done some work on this. I've done some work, especially in retail, around these kinds of intelligent solutions that know when to adjust the temperature on a cooler case because it knows what time of day or how many people are in the store and how many times that door is going to get opened. So we're going to crank down the temperature just a little bit, and it just does it. And we don't have to have a data scientist always watching the data feed and watching a trigger, watching a report, getting an alert and taking action. we still do a lot of that, but these kinds of smart devices are starting to get really interesting as well. Where have you seen some of that kind of thing going on?
Yeah, so some of it, and I've seen a mix. Some with devices that are more responsive or reactive, like the cooler case you mentioned, that kind of thing. Even systems that adjust, say, based on so a whole bunch of them come to mind. I'm trying to think which ones I can talk about. Well, systems that adjust, for example, how much water should I use in a, let's say, watering the lawn. I'll just use that as an example. Um, is it already wet? Is it raining right now? Is there a high likelihood of rain? And can I save some water by just minimally watering the lawn if there's a high probability of rain, or maybe not watering at all if it's a super high probability? Um, that that's an analogy to some of the industrial systems that we've seen that are very, very
Yeah.
similar kinds of things. I've also seen it in, and not so much in the device reactive area, but in changing behavior of people. We talked about hand hygiene as an example of that, and using so one of our customers that I can talk about because it's a public case study is Gojo. They make Purell. So a lot of times I say Gojo to people, and they look and I say Purell, and they go, "Oh
Yeah.
yeah,
Yeah.
I've seen the name on the back of the Purell. I remember that one now." Or if people work in shops like auto shops and things like that, a lot of the hand sanitization stuff that they use in those, like degreasing hand soaps and whatnot, all Gojo. So if
Yeah.
you look
And that, I
around,
mean,
you'll
that's where
see
I
them.
think of
Like
the
now,
Gojo brand. Yeah, absolutely.
yeah. And for folks who are watching, now that it's in your head, you're going to see it everywhere. It's like every bathroom you go into, or in
Yeah.
hospitals and things like that. They were working on hand hygiene solutions, and there were actually a couple of different things that came out of this. But the idea was, so 80% of infections in hospitals are caused by poor hand hygiene. Basically, someone is spreading the infection from their hands. Not, you can't avoid everything, right? So I've even seen this where you'll go and you watch someone and they'll sanitize their hands, and then they'll straighten their hair, and you just sanitize your hands and then you put them through your hair. Probably not a big deal, but might be a big deal, because you may be carrying germs, things like that. Um, so hand hygiene was a sort of an interesting thing for them to solve. And the idea was to monitor when people came into a room. And this was 12, easily 12 years ago that we started this journey with them, 10 years maybe, um, that we started this journey where we didn't have as much of the sophisticated technology, like Connect sensors and cameras and things that we have today. It was just simple. There's a motion detector. Someone came into the room. What's the gap between the time someone came into the room and the time that the sanitizer triggered? And we could watch that gap, and then we could watch, okay, does the hand sanitizer trigger on the way out of the room? Because that's the idea. You're supposed to sanitize on the way in and on the way out. And just monitoring that alone and letting people know with, here's a dashboard at the end of the corridor that's showing hand hygiene compliance rates. Now people are going to pay attention. They're going, oh, okay, I really should be doing this because our rate is low, and the next floor down, or the next unit over, they have a higher rate. So we're gamifying it a little bit. We're gonna bump our rate up by making sure that we keep our hand hygiene going. That was a really simpler system, and now they're working on even more sophisticated ways of knowing, not necessarily identifying that you, um, Jeff, are a bad person because you didn't sanitize your hand,
No.
but letting you know that, hey, you're walking towards the patient's bed and you didn't sanitize on the way in. Or when you sanitize, I know that, okay, you're good to go. And as you walk around the room, if someone else comes into the room I know, oh, they need to sanitize as well.
Yeah.
So that's the simple version of it, I guess.
Yeah, putting the sensors and the intelligence system and the people and putting in a system in place where they work together makes the
Mhm.
whole process smarter and it
Oh, yeah.
becomes an assistant to the people that, there's change management and people are going to need to get used to these kinds of things. But once you start putting the smart devices in place in such a way that it makes everyone more effective and it makes it easier to do their jobs and makes the whole environment much more productive and safer and better outcomes, that makes a big difference. So then you're taking,
It's huge.
yeah, then you're taking our IoT plus human. And anytime we take
Mhm.
intelligence plus human, computer intelligence plus human, it's a multiplicative factor. We see this
Yep.
in chess. Uh, computers can beat humans in chess, 10 times out of 10 these days. But humans and computers can beat computers in chess. So
Mhm.
it's putting those
Yeah.
systems together, putting intelligence plus humans together, where you really get some really of the best and the most interesting outcomes.
Absolutely. And they were super smart the way they designed it. And I think this is kind of key for any IoT system. It needs to be non-intrusive and helpful. Like
Yeah,
it has to do something that you couldn't do before, or maybe it makes it easier to do something that you did before, but or automatic. So turn on the lights when I walk into the room, and 5 minutes later, when no one's around, turn them off. That's non-intrusive and helpful. And yeah, in that case, it's something I could have done before, but it made it easier.
yeah,
And Gojo did that same thing, and that's kind of their design principle behind it was it shouldn't be intrusive. People shouldn't resent it, and it actually turns out people really embrace it. Um, and some side benefits of it is that okay, and this is where we talk about collecting that extra data, right? So what data do we have? What do we know? Well, we know that there was a dispense and that someone cleaned their hands. That's great. We also know how much product is in that sanitizer,
yeah,
in that inside that refill. And think about the solution prior to IoT, prior to having sensors on these, is we have these things all over the hospital, soap dispensers, sanitizer dispensers, and it's your job to make sure that they stay full, that we don't run out of soap or sanitizer. So you have to roam the hospital multiple times a day checking these things. And if you're really smart, you're going to keep track of, okay, this one seems to go a little bit faster. And, I've noticed that that one doesn't get used as much. And you'll start to gain some knowledge and you'll figure it out. But what if instead I have a report that just shows me the level of each one?
yeah,
And I can just say, hey, Jeff, this one, and that one all need to have their product replaced. The rest of them you can ignore. Now you don't have to spend all of your time roaming the hospital. You can be doing something else and just go target the ones that need to be refilled. That's a side effect
yeah.
and sort of something that wasn't initially the goal, but it's something that came out of this system. And there are other things like that
Yeah.
in simple or even more sophisticated systems that will keep coming out.
Ecolab is big into sanitization, but sort of more for hotels and restaurants and that kind of thing. They
Mhm.
ran into a similar situation where they started looking at data and they were actually able to tie that kind of data on usage and the amount of product that was being used over periods of time and tie it back
Mhm.
to health and safety inspection violation events. And they actually ended up turning
Okay.
that into a proposed, I don't know how far they went, but it was proposed service that they were going to sell to, hey,
Mhm.
McDonald's, subscribe to our service and we will guarantee, we will build into the contract fewer health and safety inspection events if you follow the program based on the data that we're getting back. Because the whole system
Yeah.
starts to get more intelligent and everything
Mhm.
gets interesting. And now we're getting bigger. So now we're getting
Yeah.
hospitals and now we're getting, restaurants and hotels. Let's even take it one step bigger. because this is an area that really starts to get interesting in my head, is smart cities. And there's experiments
Yep.
going on. There's cities that are doing this kind of thing, but this is where you can really start taking some bigger pieces and putting them together.
Hmm.
I talked to last year, I talked to the City of New York water treatment facility, and they have this vast interconnected set of sensors and internet connected devices across their water sourcing from, I think, from the Adirondacks and where all the reservoirs are coming from, all the way
Hmm.
to the water sterilization and treatment. And they know how to tune which of their treatment lines to turn on and off, which of the UV
Right.
bulbs they need to be switching in and out, all because of this
Right.
network of parts of the internet connected devices all across that network. And that's just one little piece of a smart city. Have you
Hmm.
have you worked with any government agencies out at probably not? This is few and far between. I mean, I've got a list of
Hmm.
some of the top cities, and Detroit isn't
Yeah.
on my list right now. But
Right.
Singapore, Zurich,
Yeah.
Oslo, have
So
you done it?
we did some work on a smart city initiative a while ago at a really high level. I haven't worked with any on the detailed architectures. What we worked on was more so introducing one of the clients to the concept of smart cities, talking about what things to kind of expect and enable, and then looking at what's something that's called an ontology, or basically think of it as people understand the term network in general. A network is just when one thing connects to another thing, and usually people think of it as internet network. But networks can be other types of connections as well. And the more general term for that is graph. And the idea behind a graph is that you can have things like, well, there's a city, and inside of the city there are streets, and on the streets there are street lights, and in the light there's a bulb, and in the bulb there's a sensor that tells me if it's day or night, and there's a sensor that tells me how much current the bulb is drawing, and so on. But the idea is that building this graph of what's happening in the city, something that we call a digital twin, not the
Hmm.
digital twin that sort of engineers are used to. Engineers have a different definition of that.
Yep.
But in the IoT space, a digital twin is really just that graph of the relationships among those things. And it might even include people, like, oh, Jeff is the administrator of this particular city and has certain access. And, Stacy is, maybe just a stakeholder and I can only view certain things. But all of that kind of stuff forms together. That's the level that I've worked in terms of smart cities. Now, with other areas, we've gone even further. So some of my customers, we've helped them actually build out those digital twins and deploy the devices and get the data and push the data into the twin models and things like that. So I can't tell you exactly which customers, but I can tell you most of the customers I deal with are automotive, manufacturing, healthcare, those types of customers. And the manufacturing, we do work with discrete and continuous manufacturers.
Yep.
And so in those types of scenarios, we've actually gone and built these things out in a much more detailed level. And go back to the Gojo example, we haven't done this with them yet, but you could imagine that there's a step along that path where I can go and look at this digital twin model of, say, a hospital and see everything that's happening with all of my healthcare devices in the hospital, including things like my soap and sanitizer dispensers. And we worked with Stryker on bone saws in the
Oh
operating
yeah,
room and some other things.
Strikers is
Imagine
very
that
cool.
being part of that. Yeah. We actually, I looked that way because we actually have a little bone saw sitting out on a demo table out there. No battery in it, so don't come looking to saw any bones. Um, but yeah, those are the kinds of things that when we get into that level, that's what we're really looking at.
Got it.
It's pretty exciting.
I love the concept of digital twins and have done work with digital twins as well. And there's a couple stages there as you're describing, and there's different ways to talk about them. once you've got a bunch of data and you put that into a sort of a digital twin model, then you can get a better, more accessible picture of what's going on. You can take all that data for what's going on across my city or across my factory, across my hospital, and I can get a better view of what is happening. And I can dig into that data and I can roam around. And the way I represent that in some really fun ways could be some sort of graphical or even virtual reality way for me to, or augmented reality. I can walk the hospital and I can see data all around me.
I was saying, when you worked on those things, what were some of the key value things that you got out of that? Out of the yeah.
The value is it's merely interesting to be able to take all of that data and put it together and visualize it. In the same way that you're taking a bunch of data feeds, you put together stuff in a big data lake, and you can visualize the information out of it and make better decisions. Where digital twin starts to get really interesting, and this is where it's sort of the advanced step where you start going with a digital twin, is where you can start using that to do simulation. You do the simulation and the what if analysis and the predictive, so that you can look at your hospital and you can start to say, well, now we're seeing we've got, more infections popping up in this area of the hospital. Why is that? Well, that's because it's closer to this area. What if we moved those two departments away from each other? What would happen? And the digital twin and advanced digital twin model allows you to start shuffling things around. And they use these in manufacturing all the time to great effect. And they're pretty advanced in that way, which is, how could I rearrange my manufacturing line, so that things flow more efficiently and we don't get bottlenecks and I don't have a bunch of my Purell bottles that I'm piling up in this area. So you move things around with the tools and you see what happens. So that's where the value starts to come through. Because now to do that in person, to do that for real, to move a department and see what happens costs $1 million in a hospital. To do it in a digital model, you could try it 5 different ways and see which is the best way and then go implement it. So that's where we're getting the best effect. In fact, I've got a colleague at Avanade, Tor Schuler. Maybe we should talk to him at some point. He's done IoT and digital twin in manufacturing that's getting sensor data off of machines that's looking for high impact gas outflow that affects carbon footprint. So methane in particular and CO2. But yet, so he's got all of these sensors on these devices, and he can watch the operating parameters and start to identify when in a controlled environment, the gases are starting to outflow. What RPMs are you running at? What voltages are you running at? And if you run it under these parameters and this temperature, we know that your methane exposure is going to go up. The reason that's interesting from a sustainability perspective is you can't run that kind of sensor set necessarily always in the field. You've got some of these gas lines that are out in remote locations and it's windy, and that kind of sensor set doesn't work. So having a digital twin model that can simulate and understand what's going on and when you're going to get that, and then watch the operating parameters of some system where you can't have sensors on it, the digital twin can tell you, hey, we know what's happening now because that twin has this intelligence built into it. So that's where the sustainability model for digital twins is getting really, really interesting.
One of the amazing things to me, I don't know how you feel about this, but I'm curious about this. One of the amazing things to me is when back a few years, 15 years ago, 20 years ago, the idea of being able to do this stuff was just prohibitive because it was so expensive. Yeah. And now it seems like everywhere you see this stuff, like even in art exhibits. You go to the Maker Faire, if you've ever been to the Maker Faire, and if you haven't, mind-blowingly cool. But artists and creators and people are using little microcontrollers in everything. And some of the stuff is internet enabled, so it kind of counts as IoT. Some is not. But still, it's just the idea of cost coming way down on this stuff, just making it way easier.
Yeah.
I know. What are your thoughts on that one?
That is a great segue to a thing that I did want to talk about. I've got, let's see, I think this just came out in the news. They've been working on it for a little while now. They put a Raspberry Pi Zero on a CubeSat. This was Utah State University. So the students project designed this satellite. A Raspberry Pi Zero, a $15 Raspberry Pi board, is doing sensor data gathering and running a whole satellite and is now out in space. And just this week, we got the confirmation back that it's working. It's out there in space. It was dropped off from the International Space Station. Everything's working. But in that case, and I know you even have some better models, but that is taking all of that kind of power where we can run AI models on a Raspberry Pi Zero. We can connect a whole bunch of sensors to it. We can put all of that intelligence on a $15 board and stick that with a cellular connection, stick that in some interesting place connected to a solar panel completely off the grid, doing something interesting and doing something intelligent. So you're absolutely right. It's getting really fun what we can start to do. And I know you personally are engineering some new things with some of these IoT internet devices and sensors. And well, I mean, Microsoft has theirs too, but what have you been working on?
Well, so one of the things that I actually wanted to point out too about the Raspberry Pi Zero, it's a $15 or less, depending on which one you get, board. And it runs Linux operating system on this thing that's just, a little bit bigger than a stick of gum, if people remember sticks of gum. But it's just amazing that something that tiny is running, full-blown Linux operating system, which is just really cool. And for a lot of applications, that's what you need, right? You need an operating system. You need that sort of overseer. And in some cases, actually, the Linux operating system, we can talk about security at some other point, but sometimes it's sitting there in the case of something like Azure Sphere, which is a Microsoft product. Azure Sphere is a microcontroller, but with a Linux operating system sitting next to it to provide security. And the idea behind it is that that operating system is needed to do things like, we're going to check certificates and do all kinds of package signature checks and whatnot, but to make sure that the code that's running on the microcontroller can't be corrupted and hacked. But you don't always need that. You probably want the security in a lot of industrial applications. You don't need it in every application. You also don't always need an operating system. So occasionally you just need these little microcontrollers, like this one, also from Raspberry Pi. This is the Raspberry Pi Pico, which is a $4 microcontroller. This particular one is running a version of Python on it, so you can actually run there are two versions, MicroPython, and then a fork of that one called CircuitPython. I have another one sitting here that's running just C++ code, but this is a $4 piece of hardware that is a microcontroller that's programmable, and in some cases, so this one does not have a network on it. This one is a different one. This is an older ESP 8266. That one has a network on it. Or you get these little boards that have not just network, but this one has. So this one has a lot of stuff on it. It has a network sensor. It has a security chip on it, so it can store secured information. It has a magnetometer. It has pressure sensor, temperature, accelerometer, gyroscope, audio out, microphone, like all this stuff on this little board.
Yeah.
That you can then program to do all kinds of things, and adding in extra peripherals and things like that. Even little peripherals like this little tiny thing. This is an inertial measurement unit. You're going to build a robot, you probably want one of these. It'll tell you what direction it's going and whether it's tipped over, and like all of these types of devices have gotten so cheap. They're hobbyist level cheap. And so I end up building a lot of things. Actually, the Azure Sphere one, I mentioned that I spent a weekend attaching that to one of the Gojo hand sanitizers so that we would be able to add a secure microcontroller into that architecture and test out how well it was going to work. It worked pretty well. And they're actually looking at incorporating Azure Sphere into all of their future designs. So that's kind of a cool thing. But I also do other hobbyist level stuff. I build robots and things with these little microcontrollers and just all kinds of just fun things.
Well,
So,
robots,
yeah.
especially with their intelligence in the cloud, is one of the ultimate cool Internet of Things devices. You'll have, well, eventually we'll have robots roaming the hospital, replacing the Gojo gel in the sanitizer packs as
Yeah.
part of an intelligent system, and we won't have to do it at all.
I was one of the robots you mentioned, intelligence in the cloud. One of the robots that I have been working on, and I haven't touched this one in a little while, but it has both onboard intelligence and intelligence in the cloud. And its cloud brain, if you will, connects into cognitive services, which is a Microsoft kind of canned AI system. But you can get these things anywhere. Some are free, some are not. But the idea of having it in the cloud and having it available to developers, making it easy, is a really innovative thing. I was
Yeah.
able to take the robot and have it essentially just take a picture of the room, send a picture to the cloud, and get data back about what it's seeing in the room. So this robot's onboard intelligence can navigate around, it can do some things, but now it's able to use its cloud brain and say, oh, I'm sitting in a room and I see a man sitting behind a computer with a cup next to him and a mouse and keyboard. And it'll tell you things like the predominant color in the room and what shapes it sees and give you a little caption, just all these kinds of things that the cloud can enable so quickly and so easily on a device that otherwise wouldn't have that capability.
And this is excellent. So this is getting us to the final bit I wanted to get to, which is some of that future. The idea of why do we have some of these things connected to the internet? There's a couple reasons. One is getting some of the data up to the internet. That's where we can start collecting it and mashing it up and asking interesting questions. Another reason, which you're getting to, is when we start thinking about intelligence and artificial intelligence and machine learning models, there's stuff you can run on the device, and there are parts that will run on the device. But as you're suggesting, there are times when there are bigger models or new models or interesting questions that we need the robot to suddenly be able to escalate to a different part of its brain, a different model to ask those questions. And there's that I part of the thing that helps with that. So if we even look into the near future and 5 years out with 5G coming online, there's some interesting things that 5G brings to that picture, which is an intelligent edge infrastructure that allows us to run some of those models in the cloud, some of those models closer to the device on the edge with super low latency, and then some of those models on the intelligent device. And now you've got a robot which potentially is driving around the streets of San Francisco delivering meals, and they've trialed this. This is going on. You can look it up. But maybe it gets into a more difficult situation, and it needs to escalate to a different kind of model to navigate a particular situation or validate a delivery drop-off. And if it's a very near-term, low latency situation where, like, is this a stop sign or not? Am I going to get run over by a car? That might be escalated up to something running on the edge. If it's something that can have longer latency, there can be much more complicated models running in the cloud. Now you're putting these cheap devices with massive intelligence running on the edge and running in the cloud, and you can start to do really, really interesting things. This is where you start to bring.
Just to be super clear on that term edge for people who don't follow the space, is that the edge is kind of, as you alluded to, it's the compute that's running right on the device. And sometimes it's right on it, sometimes it's sidecar, but there's no internet connection that it needs to negotiate to talk to the edge. The edge is that compute that's right there. So in my robot, that's its local brain. And then there's the cloud brain, which is the internet. And there are times when, yeah, like you said, there's stuff that needs to happen on the edge. We don't always know what that is ahead of time. And so these systems that are sort of hybrid can make that decision of, hey, I need to go out and find this thing. I'm going to talk to the cloud brain. And it might be not just my brain, but a collective brain. It might be that this is something I've never seen before. It's not in my knowledge base, but I'm going to ask the world. I'm going to ask the whole of the internet for this and get an answer. And hopefully it's an answer I trust, because that's the other thing we have to worry about. But if it's an answer that I trust, then I can use it and go on with my day. But maybe I make the decision that, hey, this is something that I need to know all the time, that I need to have here locally. So I'm going to pull that down. I'm going to now make that a part of my local edge brain and not just part of the cloud brain, so that I can make those immediate decisions. I just learned about
Yep.
a stop sign. Okay. Instead of me going to the internet every time, it's like, get on the phone and calling Jeff and saying, what am I supposed to do with that red sign? Now I just remember it. And now I know I need to stop
Yeah.
the stop sign. That's an extreme example, because obviously we would never have that just in the cloud. But there are things like
Yeah.
that come
Yeah.
up
Right.
where
Right.
you need to
Not
learn.
what is a stop sign, but there's some sort of more advanced recognition model or a new recognition model which solves some problem that maybe that we haven't even thought of yet.
Mhm.
And then a few episodes ago in our 5G episode, we talked about the one more layer to that edge model, which is as the 5G network stacks go online. We've got these 5G antennas spread all over the place. There's actually a compute stack that's running at the MEC. And we've got startups and we've got the providers that are starting to put boards into those blade computers running in there, which can run super local, but compute services and AI models at that layer, which is sort of it's that hybrid that you were talking about in between.
Yep.
So there are
Absolutely.
things we can put in the cloud. There are things we can put on that MEC. There's things we put on the device. And then moving those models back and forth or updating them in real time, because we want something we now have something that's more accurate. There's some new food is on the menu and I need to be able to recognize it. And I don't have a recognition model for ramen yet. And now I'm delivering ramen. I got to make sure this order's right. I don't know what it is. And that's part of the point. We don't know. We don't know yet, but there's a bunch of new technologies that are coming together. And Aaron Reich likes to talk about this, which is once you start to get that crossover of the trends, the emerging tech trends coming together and crossing over and orchestrating across them, like AI plus 5G plus IoT, that's where really interesting things are going to start happening in the next 5 to 10 years.
Yep,
And
absolutely.
that's the only way we're going to get things like self-driving vehicles. We're going to have to put a whole bunch of these things together.
Yeah, and it seems like that's the case with so much of our technology, is that not only do we have to put these things together, but it's the community that makes it work, because no one person knows everything to be able to do all of it, to put all of it together. So it's really that networking aspect of the people involved that really makes the whole thing work.
And you kind of described that in a casual way. Let me go out and ask the world for a model which does X.
Right.
But that can be done in a real way. We could have a library, an open ecosystem of APIs to these different models to answer different questions, all coming online at different times and being out there. And maybe at a moment's notice, I'm able to switch off. Now that's
Right.
pretty pie in the sky. It's usually typically much more difficult than that. But that would be really interesting. And then you're really crowdsourcing intelligence at runtime. That's some future thinking.
Yeah.
One last question I had for you. One of my hypotheses, and I don't know how committed I am to it, but one of my hypotheses is that the ultimate IoT sensor is the camera. Just the camera looking at things. And this is the direction that Tesla decided to go, which was, yes, we can have radar and LiDAR, and we can have all these kinds of sensors which putting together pictures of the world. But with the way cameras work, and if we look at the analog version of this in humans, visual information tells you a whole heck of a lot of what's going on. And there's advanced versions of very, very sensitive cameras that can watch the vibrations on a bag of Doritos through a window and tell what conversation is happening in that room. And the FBI did, or some government agency did some experiments on this.
Sure.
So am I crazy, or is the camera the ultimate IoT sensor of the future? We just put cameras everywhere, although
really,
everybody's going to hate that, but
yeah.
or
but
both.
I do have a question about that. Are those mutually exclusive choices?
Well, there we go. I knew that was coming. I set myself up for that.
Okay, yeah, you did. No, I actually one of my friends, a guy named Kyle, who I work with at Microsoft, has a saying that I love and I adopted, and that is that he has strong opinions that are weakly held, which, in other words, means you have an opinion about something, you believe something to be the case, but you're open to being proved wrong. Like, I'm okay. In fact, I will have a good day, as Neil deGrasse Tyson says. I'll have a good day when I'm shown to be wrong about something, because that means I learned something new that I didn't know before. Yeah. Now, so on the sensor, to answer the sensor question, I don't think you're crazy. I think that, can you get things to work? I think Elon's probably on the right track. You can get it to work. We do it. So like, there's part of the proof there. The fact that humans can do it means that it can be done. Now, what can do it, what the next level of technology is that can do it, that remains to be seen. But I think Tesla's gotten so close that they're basically proving it, right? They're showing it to be done. Now, here's the other part of that, and the part of the discussion or argument that I will at least say we have to ponder. Think about what happens out in the world of non-human animals and what they sense and what they see. If you're a bat and you're flying around and it's relatively dark, you don't run into walls, and you're not using your visual spectrum for that. They're echolocating.
Yep.
Or I may have some animals that can see places in the spectrum where, it's where we can't see, or they can hear parts of the audio spectrum that we can't hear. The question to ask is, are those things useful? And what's the cost in terms of money and compute and complexity of adding those into our systems? So,
Yeah.
Some of the sensors may not be all that great. Like, I look at LiDAR and I just go, okay, it's interesting, but on a dusty, rainy day, a dusty day or a rainy day or whatever, it doesn't work as well. On the other hand, radar works pretty well. So, okay, maybe I have that, and maybe I have cameras that can see outside of the normal visual spectrum, so that when I'm going down that road at night and there's a deer, running across the road. This was something that I can't remember which car, but one of the cars did that years ago and didn't really catch on. But now that it's cheaper and maybe more accurate, it might. But those are the questions that I ask. Is, yes, I can do this in a certain way, but can I simplify the equation by adding an additional sensing capabilities? Can I make this better, safer, superhuman by adding in additional capabilities? And it's already going to be superhuman because it doesn't get distracted by stupid crap the way we do. It's going to pay attention all the time. So it's already going to be better, but can I make it even, better further without increasing the cost way too much? Because that's the other constraint, that if you're selling a product,
that's good.
You don't want the cost to get so out of hand that nobody can afford it, and it's not going to become ubiquitous. So I think Elon's done a good job. Elon Musk and Tesla have done a great job of balancing those things. As technology gets cheaper and better, I think Elon Musk will be one of the first people to say, hey, let's relook at this and let's adopt this newer, cheaper, better technology. He's not shy about changing things. And I think he's one of those people who has strong opinions, sometimes more strongly held than maybe I would, but I think he's okay with changing his mind, which is everybody should be okay with that.
You're already getting me to a little bit there in a good way, bringing up that idea of how cheap is this stuff getting. And yes, while we could go so far with just cameras, and maybe that is the ultimate or the
Right.
primary device we'll start with things coming down to it costing cents, pennies on the dollar to add additional sensor capabilities into it, and then having this complex sensing model that can put extra information together with the visual picture, then things potentially get much, as you said, superhuman. And why not? Why would we limit ourselves? If there's a reason to limit ourselves, then fine. And if we start with the cameras and put those everywhere we want to be gaining information, that's a great start. And then we can figure out what we can do with it. But where it makes sense, or where we have an opportunity and where it's really cheap, let's augment it. Let's
not artificially limit ourselves. Let's make sure that the limits are actual, that they make sense, either from an engineering perspective or a monetary perspective, or sometimes from a social perspective, which especially comes into play in medical scenarios. But yeah, we don't want to artificially limit ourselves. And then there are still engineering problems out there that some of them are simple, some are really complex. We'll see. But I think that as things progress, as things get cheaper, as things get better, think about, we were talking about machine learning, and on that little Raspberry Pi Pico that I showed earlier, you can run ML models on a little thing like that. We wouldn't have been able to do that on even extremely powerful computers just 20 years ago. So, why not take advantage of those things?
Well, speaking of superhuman, you, my friend, are superhuman, and I really appreciate having you on. This has been an amazing conversation. We've blown through the full discussion here. We could probably go on for a couple more hours, but this has been great. This has been fun. This is the kind of discussion I'm hoping to have with this, which is, where are we at today? What's interesting? What parts of the future are here already, and where is it going to go? So, thanks for that.
I really had fun. So
yeah,
absolutely.
Excellent.
I'll do it anytime for hours.
If people do want to catch up with you and get connected to Microsoft or the MTC, probably with you directly, I think that's what I would do. How should they do that, Stacy?
So probably the best ways, I'll call it on-ish, if that's a word, Twitter-ish, Stacy H3, so STACYH3. And then LinkedIn, my profile name is my full name, Charles Stacy Harris III. So no E in Stacy, and the third is just the three little I's at the end. Pretty easy to find, or just do a Bing search for Stacy Harris, Charles Stacy Harris, Microsoft. There's some other Stacy Harrises here. But, yeah.
Again, thank you very much. This has been great, and we will talk again soon.
Pleasure. All right. Yeah, sounds good. Thanks a lot.
This has been a Nexavise production. For video, links, and to support the show, please visit nexavise.com. That's NEXAVISE.com.